S given below contains data from a study on the effect of training in quantitative aptitude. Quartz 1 relates to score before training and Quartz 2 relate to score after training. Here that QATS, Quantitative Aptitude Test Score, it stands for that. Now look at the data set. We have two categorical variables, gender and faculty. And faculty is coded as ASC, Arts, Science and Commerce. Quartz 1 is the score the students got before training. Quartz 2 is the score students got after training. This is all about the data. Now, this data we have to enter on SPSS and perform these set of analysis. So the first question is mean and standard deviation of Quartz 1 and Quartz 2. So I have entered it on SPSS. Let us check whether the details are correct here. Yeah, the two categorical variables are coded, there is no problem. And both are string variables, others are numeric. And also the first three, serial number, gender and faculty, they are nominal. And Quartz 1 and Quartz 2 are scale. So what is asked is mean and standard deviation of Quartz 1 and Quartz 2. We can come to analyze descriptive statistics and frequencies. So put Quartz 1 and Quartz 2 in the right side box and come here, select mean and standard deviation and continue. Frequency table not required. Proceed. So here you get the answer. Mean of Quartz 1 is 3.07 and Quartz 2 mean is 3.77 and the standard deviation also have obtained. So question number 2, mean value Quartz in each faculty, categorical analysis. So first you come here, go for the select case and we need to use it's not select case, just we need to go to split file. Here in each faculty, so faculty wise division we have to do. Okay, and compare groups we can keep faculty wise. Proceed and go for the descriptive status frequency. Before that, just check was the question again. Mean of Quartz 1 in each faculty. Okay, so Quartz 2 not required and only mean is required. Standard deviation is not required. Proceed and here we get Quartz 1 in arts faculty mean is 1.63, commerce faculty mean is 2.92, science faculty mean is 4.4. Now the next question, mean score of Quartz 1 on male students of science faculty. Male students of science faculty, their mean score. So what we need to do, first of all, when we come here, we need to go and remove the split file. Analyze all cases, do not create groups here. And now select, go to data, select cases, if condition satisfied, if. So gender should be equal to male. So within double quotes capital M and faculty should be equal to within double quotes S science. Okay, here we are putting two conditions, so there is an and in between. Now proceed. You can have a look at the data sheet. Say all other things are cancelled. Here is male and science faculty. That alone is selected. Now, what you need to do, calculate the descriptive statistics, and mean is already selected. Okay, so I think it's about quarts 1. We'll check it. Yes, quarts 1 of male student science faculty. So click OK. So in this category, there are 10 students. Their mean score is 4.4. Now, as usual, please remember that we have to go and cancel the select case. Select all cases, so it is cancelled. And now data sheet, we can see all the crossbars have gone back. Now, go to the next question. Bar diagram of quarts 1 score. So that is again easy. Come here, analyze descriptive statistics, frequencies. Quarts 1 is there. In the chart, you choose bar diagram. And statistics, nothing is there needed. So just check here, click OK. Now the graph will emerge. Just wait a minute. Yeah, it's processing. Yes, it has come. This is a quarts 1 bar diagram. Next one, line of regression of quarts 2 on quarts 1. So come to this. Analyze a regression linear. Dependent variable is quarts 2. Independent variable is quarts 1. And click OK. So many tables it writes out. Look at the last table. The constant, that is A, 1.287, and quarts 1 coefficient, that is 0.809. So A is 1.287, B is 0.809. So the line of regression will be y is equal to 1.287 plus 0.809 times x. That's the line of regression. Now the next question, does the hypothesis that quarts 1 male students are better than female students? Sorry, does the hypothesis that in quarts 1 male students are better than female students? So how to test that? Before we go there, here testing, there's a slight difference in the procedure. Say, we'll look at what we have learned last time. Say, logic of acceptance here. Say, last time we used to mark alpha at the tail of the curve, and we will mark this much region as acceptance region and this much as rejection region. And afterwards, when we calculate a test statistic, Z or T, whatever it may be, if it falls in the acceptance region, we write it accepted. If it falls in the rejection region, we write rejected. But here, the procedure is slightly different. See, if it falls here, area to its right, we will consider. Say, if the calculated is that falls within the acceptance region, area to the right of Z will be greater than alpha. Means this region. See that yellow shading. So that is greater than alpha if it falls here. So what our rule is, thus if the area to the right of Z is greater than alpha, then Z falls in the region of rejection. We falls in the region of acceptance. We accept H0. Now, when do we reject? Say like last time, the setup is here. Suppose T falls here or Z falls there. So the area to its right will be only this. That will be smaller than alpha. If the area to the right is smaller than alpha, we reject H naught. Thus, if the area to the right of Z is lesser than alpha, we reject it. So this area to the right, whatever is shown as yellow mark, in SPSS and other softwares, they call it significance or p-value. So looking at the significance or p-value, we arrive at the conclusion. Here we are not going to look into the tables. Okay, so we'll come back to the testing. Test the hypothesis that in quartz 1, male students are better than female students. So what we need to do, come here, analyze and compare means independent samples t-test. So in quartz 1, we are comparing, and comparison is based on gender. So grouping variable is gender, and which are the values? One is M and another is F, male and female. Okay, now click OK here. Answer have come. Now this table, how to read that? Say there are two assumptions written. One is equal variances assumed, and second is equal variances not assumed. So as you remember, there are two formula for t-test based on these assumptions. So here the two assumptions are written. We should accept one among them. And how to accept one? There is something called Leibniz test for equality of variances. So that test statistic is here, and the significance also is given here. That significance is 0.45. If alpha is 0.05, 0.45 is much larger than that. That falls in the acceptance region. Null hypothesis is accepted. So if null hypothesis is accepted, what is the null hypothesis? Variances are equal. So equal variances are assumed that we accept. So therefore, for further discussion, we'll be looking only to the corresponding top row. Okay, the first row only will be looked. So here the t value is 5.4, much large value, and significance is 0.30 something, that something has not come. So that is two-tailed significance. But remember that which is favorable to male students, so we need one-tailed significance. So divide this 0.30 something by 2, you will get 0.30 something again, that is smaller than 0.05. So that falls in the region of rejection. We reject the null hypothesis. What is null hypothesis? There is no difference between male and female. That is rejected. And we accept the alternate. Alternate will be male students are better than female students. So we conclude that. Now come to the next question. Does the hypothesis that training is effective? And to test whether training is effective, we have quartz 1 and quartz 2. Before training, after training, paired samples. So we need to use paired samples t-test. So we have to come to compare means and come to paired samples t-test. Here we have to choose quartz 1 and put it as variable 1, quartz 2, put it as variable 2, and perform the test. So here that difference is written, and further the t value is minus 5.88 and significance is 0.30 something. So that is a much small value than 0.05. So actually it is a one-tailed test. So divide by 2, you get 0.30 something still, and that is lesser than 0.05. It falls in the region of rejection. That means we are rejecting the null hypothesis, which says there is no difference between the two sets of scores. And when you reject that, we accept the alternative, which says that there is an improvement due to training. And the next question, test the hypothesis that quartz 1 is below 3.2. So to test that one, we are comparing with mean, you are comparing with one particular value. So here, you come here, analyze descriptive compare means and one sample t-test, and which is the variable quartz 1, and lesser than what was the value 3.2. Yeah, 3.2. So there you write 3.2. Click OK. Again, t-value, which is minus 0.59, is a very small value. And to tail significance, we need one tail significance. So this two tail significance 0.55 should be divided by 2. So you will get a value something like 0.275, much greater than 0.05, that falls in the acceptance region. Null hypothesis accepted, means the mean quartz 1 is nearly 3.2. And similarly, we can test the next one. Test the hypothesis that quartz 2 is above 3.5. What you need to do, come here, come to this compare means and one sample t-test. Quartz 2 is above 3.5. So you need to check this 3.5 here and click OK. So here t-value is 1.254. So 1.254, and that is two-tail significance is 0.22, and we need one-tail significance. So divide by 2, so you get 0.11, much larger than 0.05. Falls in the acceptance region. Again, the null hypothesis, which says that quartz 2, mean quartz 2 is 3.5, will be accepted. Now come to the last one. Of course, there are further questions. Question number 10. Test the hypothesis that on the average, girls improved better than boys. So we need to calculate the improvement of all and half. That's a new variable to be calculated. So come here, and improvement means quartz 2 minus quartz 1. So come to transform, compute variable, right here, improvement. And here you put quartz 2 minus quartz 1. And you get the answer on the screen now. So these are the improvements. Now the question says that test the hypothesis that girls improved better than boys. So for that, we need to go to analyze, compare means independent samples t-test. So here quartz 2, 1 is removed, and we'll put improvement. And comparison between male and female remains, so click OK. So you get the answer, t-value minus 2.4. And it's a one-sided test. So two-sided significance is given. Before that we need to go for the 11S test. Equal variance assumed or not. So the significance here is 0.06, larger than 0.05. Null hypothesis is accepted. What is the null hypothesis? There is no difference between the variances. So equal variances is assumed. It is, we proceed through the first line. So here 0.025 is the two-tailed significance. Divide by 2, 0.0125. Lesser than 0.05, it falls in the region of rejection. Null hypothesis, which states that there is no difference between male and female, rejected, and we will accept that girls have improved better than boys. And then test the hypothesis that Quartz 1 and faculty of students are independent. Quartz 1 and faculty are independent. So it's a very simple procedure. Come here, we have to use chi-square test. Come here, descriptive statistics, and cross-tab. Quartz 1, you put it in row or column, no problem. Faculty, you put it in the other. And statistics, chi-square. Click continue and OK. You get the chi-square results here. This is the count or observed frequencies, OIJ values. Row totals are here, column totals are here, grand total is there. This is a Pearson chi-square value, much higher, 40.031. Significance, we require one-sided. The two-sided is given. Divide by 2, 0.30 something, divide by 2, 0.30 something. Much smaller than 0.05, falls in the region of rejection. Null hypothesis is rejected. What is a null hypothesis chi-square? The two attributes are independent. That is rejected. Therefore, the two attributes here, Quartz 1 and faculty, are dependent. That is our conclusion. Let us go to the last question. Test the hypothesis that improvement due to training depends on the faculty. So we go here again, analyze descriptive statistics. The improvement and faculty we need. So we'll put it here. This chi-square selected already and click OK. So it comes here. So the value is 5.347 and two-tailed significance is 0.5 divided by 2, 0.25. Much larger than 0.05. So the chi-square calculated falls in the acceptance region. Null hypothesis accepted. Means that two attributes are independent. So improvement and faculty, they are independent. This was the last question. With this, we conclude.